I think SpaceX is a collection of some of the very best humans on Earth. So Starship is obviously an incredible vehicle. It's what will take us from roughly 2,500 tons to orbit per year to over 1 million tons to orbit per year, and I think maybe even to 10 million tons per year. These are mind-boggling numbers. Highly likely we do over 1 million tons a year to orbit with Starship, and probably close to 10 million. If you can't deliver millions of tons to Earth orbit, you can't get the millions of tons that you need to the Moon and Mars to make us a sustainably multi-planet species. It's arguably the hardest thing that humanity's ever tried to do. The Starship team has done an amazing job across the board with engines, avionics, structures, launch operations. So big hand for the Starship team.
SpaceX just fired one Raptor on the next Starship and described the test as a deorbit-burn demonstration for upcoming orbital missions. And hours earlier, Elon Musk said a tower catch would probably happen in a few months, which appears to remove that attempt from Flight 14. Now, Flight 14 can still become the first true orbital Starship return test, and could SpaceX send the ship around Earth multiple times and land it in the Gulf as a full rehearsal for a return to Starbase in the future? An offshore landing could preserve most of the return profile while protecting the tower, the launch mount, and pad infrastructure in all of Starbase. The new evidence comes from ship's engine tests, SpaceX's FCC filing for a Starship Orbital Return Demo, an FAA-reviewed landing zone off the Texas coast, and Musk's new catch schedule. We're going to trace the mission change, explain the orbital mechanics, and show how a Gulf landing could test every step short of actual chopstick contact. And Flight 14 may have become incredibly more technically useful. SpaceX's Starship Flight 14 now has a different scorecard than any other flight. The tower catch appears delayed, while orbital payload deployment and a deliberate return are still moving forward. The plan seemed much clearer at the beginning of August. Musk said Flight 14 would carry viable payloads into orbit and attempt the first ship catch if SpaceX received the needed approval. Flight 13 had placed Ship 40 on its ocean target with enough accuracy that Musk believed a tower positioned there could have caught it. That performance made a Flight 14 catch sound like the next logical step. Musk changed the public timeline on August 20th. He said the first tower catch would probably happen in a few months and placed the first ship reflight near the end of 2026 or early 2027. Now, SpaceX may have been able to complete the regulatory work, but the company was not ready overall. Then SpaceX provided the strongest evidence that the orbital part of Flight 14 remains alive. The company released video of a single engine static fire and specifically called it a demonstration of a deorbit burn for upcoming orbital missions. The vehicle expected to fly next is Ship 41. A deorbit test would make little sense if the next mission only repeated the familiar suborbital arc to the Indian Ocean. Now, a true orbit creates a new requirement. Starship must deliberately slow down at the correct point so its perigee, the lowest part of the orbit, drops into the atmosphere. The short retrograde burn can lower that perigee enough for drag to take over, but the ignition must happen on time and with the correct direction. If the burn fails, the ship may remain in orbit instead of reaching its planned landing zone. In orbit, propellant will be floating in microgravity before small thrusters settle it over the tank outlets. The engine must receive liquid instead of gas when the turbopumps spin up. SpaceX has already filed for additional communications power on a mission it calls the Starship Orbital Return Demo. The FCC authorization runs from July 29th through December 28th and covers uplink frequencies for both the booster and ship from Boca Chica. The FAA has evaluated a Starship near shore contingency landing zone at least 1 nautical mile from the coast and extends as far as 100 miles north and south of the Starbase launch area. SpaceX may use that broad water zone when a ship cannot safely return to the tower. The environmental approval does not prove that Flight 14 will land there, but it provides a legally studied location for exactly this type of test. Now, SpaceX could treat a point in that zone as a virtual tower, too. The ship would follow a return corridor toward South Texas, complete most of the same atmospheric guidance, and aim for a precise box offshore. Controllers could send it to a point far enough from the pad to protect the launch site while still demanding catch-level navigation. A successful landing would show whether Starship can return from orbit and arrive at Starbase with the correct position, speed, attitude, and propellant reserves. This profile would also produce much more operational data than another Indian Ocean landing. Flight 13's ship survived intact, but recovery crews spent roughly 24 days guiding it toward calmer water near Christmas Island before engineers could inspect it. A Gulf landing near Starbase could shorten that process dramatically if SpaceX chooses to recover the vehicle and receives permission to do so. Engineers could reach the heat shield, flaps, engines, and catch fittings while the evidence is fresh. Saltwater would almost certainly keep that ship from flying again. Seawater can enter engine cavities, contaminate valves, and leave salt inside plumbing that must remain extremely clean. A recovered Gulf vehicle would still be an extraordinary test article for teardown and structural inspection, though. Musk's first reflown ship is most likely to be a later vehicle recovered dry by the tower. The multi-orbit possibility remains open because a return to South Texas depends on orbital geometry. A low Earth orbit takes roughly 90 minutes, while Earth rotates about 22 degrees beneath the Starship during each revolution. Starship's ground track therefore shifts on every single lap. SpaceX must choose a deorbit opportunity that lines up the entry corridor, the Gulf target, lighting, weather, and also airspace closures. Flight planners can design a one-orbit return, so a Gulf landing does not automatically require several laps. SpaceX could also keep the ship up longer to reach a better recovery window or gather more data. Several laps would turn Flight 14 into a serious long-duration systems test. Starship would pass repeatedly between sunlight and Earth's shadow, creating thermal cycles across the stainless steel tanks, heat shield, plumbing, and avionics. Heat leaking into liquid methane and liquid oxygen creates boil-off, increases tank pressure, and can force a ship to vent unusable propellant. Now, engineers could measure those losses across hours instead of just about 90 minutes. Version 3 carries hardware designed for that job, though. SpaceX says the ship includes vacuum-jacketed header tank feed lines, electrically driven cryogenic recirculation valves that isolate high-pressure gases, and a dedicated system for managing propellant interactions with the engines during extended coasts. Flight 14 could exercise those systems before Flight 15 or other later mission waits for a tanker. A delayed deorbit burn would provide a direct test of whether the plumbing still feeds a Raptor after the ship has warmed and cooled several times. Now, the ship would also have to manage liquid motion. Methane and oxygen do not sit neatly at the bottom of their tanks in orbit, and every attitude change could create slosh or move gas toward an outlet. Reaction control thrusters must settle the liquid before the burn while preserving enough propellant for entry and landing. Radio frequency gauges then have to estimate the remaining quantity without relying on a flat liquid surface. And the return through the atmosphere would test a second chain of systems and events. Starship must hit the entry interface at the correct altitude and flight path angle, use the body lift and flat motion to manage energy, and perform bank maneuvers to control its downrange and cross-range positions. Small errors early in entry can become large misses near the coast later on in the flight. A Gulf target lets SpaceX measure that entire chain without placing a descending, propellant-loaded ship directly beside the tower where it can explode and destroy Starbase. Now, the final kilometer would be the closest possible rehearsal for a catch. Starship would fall horizontally, control its position with 4 flaps, flip upright, ignite its landing engines, and cancel nearly all of its vertical and horizontal speed over a marked point. The ship could use the same guidance logic and commit criteria intended for Starbase, with the target coordinates moved offshore. Telemetry would show whether it entered the catch box with the right lateral error, roll angle, and descent rate. Now, the water landing cannot test everything. It cannot prove that the tower can track the ship, move the chopsticks into position, clear the flaps, receive the catch pins, and absorb the vehicle's remaining motion. It also can't test plume interaction around the launch mount or the rapid safing process after contact. Those final seconds still require a real, actual tower attempt. If you enjoy technical Starship updates, please take a second and subscribe to the channel. Now, Flight 14 has changed quickly, and the official mission profile could settle the Gulf question at any point. Musk said Flight 14 would place viable payloads in orbit, which means Starship must reach a stable path before beginning its return sequence. The ship could deploy satellites, separate safely from them, coast through one or more orbits, and then perform the deorbit-burn. The sequence would prove the Starship can complete useful work, like Starlink, and remove itself from orbit under control. Now, SpaceX also has a powerful reason to protect Pad 2. A ship catch failure could damage the tower arms, the propellant systems, the launch mount, or nearby ground equipment and delay several later flights by months, if not a year, depending on how much damage it did. A Gulf rehearsal allows engineers to tighten the guidance limits and study a full orbital return while accepting the loss of one ship. Flight 14 proved impressive landing accuracy, but a return from a stable orbit adds a deorbit burn, a different entry timeline, and 4 more opportunities for conditions to drift. A full 6-engine static fire would check Ship 41's ascent engines. That's what we're going to be looking for, while Booster 21 still needs to complete its own campaign before stacking. Flight-specific FAA licensing, maritime notices, airspace closures, and SpaceX mission page should reveal those recovery zones. A Gulf exclusion area near Starbase would be the strongest public clue that the virtual tower plan is actually real. Flight 14 has apparently lost its tower catch, but it may gain the first complete test of Starship as an orbital spacecraft. The deorbit burn test, orbital return filing, and existing Gulf landing zones support a mission that reaches orbit, deploys payloads, and wait for the correct return window, and practices a Starbase approach over water. The exact duration and landing point remain unconfirmed, but the multi-orbit Gulf profile, it's all still on the table.